Okay, hi everyone. Today's topic is about association rule mining. Basically, the point that we want to find any association between certain items. If there is a high association, we want to take advantage of it. But let's see what it works. It's basically a very common traditional data mining technique, generally as a part of machine learning analysis. And basically, it first comes from, the most famous story that might be the origin of it is from a grocery store. So they found there is a high association between the amount of beer sold and diapers. So can anyone guess what kind of association? So if in some days, especially Fridays, there is high selling of diapers and beer together. The point that notice, they also look at the age and gender of the customers, and they found, or based on the story, that married men who has babies, they cannot enjoy going to bar in Fridays. So whenever they go to pick up some diapers, they took some beers for themselves, especially on Fridays, to just get back home, take care of the baby. So for this reason, actually I have noticed before, whenever you go to the any department store like Walmart or Kroger or Whole Foods, they put diapers near to beers, because they found selling of them could be associated. So for these reasons, they put them together. So when they go to pick up diapers, they see beers and just grab it. Can anyone give me another example of association rule minings, items in the department stores that might be located next to each other?
So you can decide the line of onions that you chips, so that someone can practice with
like crackers, those. Or breakfast. Like if you go to pick up coffee, they usually put like basically a coffee filter next to the coffee, because they assume you might buy it from them together. So any other examples? Basically, whole of the supermarket designs is based on association rule. They try to find which items could be sold together. So if there's association between items, they put them next to each other so they can sell it more, because they know in people's based on people's need, probably they goes together. So let me think other items might be. At least in the Whole Foods, they put some bread near to milks, I guess.
Then in online transaction, if you buy something from Amazon or from Alibaba.com, then associated item comes immediately next. For example, I'm buying a laptop, then they provide some suggestions for buying something to buy or some required software.
Yes, it's actually a much better example you provided. So they know people who needs laptop probably are interested to buy an antivirus or like probably mouse or other items. So they want to keep you busy in Amazon.com, not going other website or not suddenly remember and just get back. So yeah, that's actually a good example. So this is a supervised learning or unsupervised learning? Unsupervised, because there is no dependent variable. There is just some independent variables that might have some association with each other. These are some examples of association rule. So in business like cross-marketing, cross-selling, store design, catalog design, commerce site design, like the Amazon that your friend said. In medicine, also could be very useful because it could be some sickness that goes together. So they can find some association between some certain illness that they can take care of it. Okay, these are some, let me introduce a way of calculating manually. Basically, there is a formula for association rule. So first of all, we have antecedents or antecedents, it could be more than one, and a consequence. Or A implies B. So these are some technical terms. So the first item is support. Is basically probability of two items, consequent and antecedent. Probability of their union, we call it support. Confidence probability of antecedent given consequent, which is equal support divided by probability of A. The last parameter is lift, equal confidence divided by probability of consequent, which is equal support divided by probability of antecedent times probability of consequent, or probability of union of antecedent and consequent divided by their multiplication. So we don't go to the mathematics behind of that, but generally speaking, if the leaf is more than 1, there is a high association between antecedent and consequence. If it's less than 1, we don't have any evidence for having a high association. So it used to be a quiz question, but this semester I'm avoiding quizzes because I'm not sure is it fair enough or not, because some of you are in class, some of you are synchronous, some of you are asynchronous. I'm not sure if it's fair, but it used to be a very good quiz question. So basically how to find like confidence lift and just finding if there's a recommendation, if you can provide a recommendation. Your next assignment, instead of quiz, we have assignment. So I give you some transaction. Basically, the most frequent application or association is through transactional databases. I mean, the databases that have like transactions. And you need to calculate, you need to recommend which items or which antecedent and consequence should go together. So this is slide looks like your friend's suggestion for association rule. Basically, like in your friend example, if lift of laptop, computer, antivirus software is more than one, and you purchase it online, they put it together. Or if you want to buy it from Walmart store, probably they put a DVD of like antivirus next to the laptop that they sell. Generally speaking, S, which is standard of supports, is showing how often X and Y go together, and confidence, how often Y go together with X. I think that should be fine. Okay. Look at this example. We have some transactions, and the items or SKUs means basically refers to the item ID. So we have 1, 2, 3, 4 as the item IDs, and we have 6 transactions. So these are the steps, general steps for calculating manually. First, we calculate the support of each item. The probability of an item happens in the transaction. For example, on item 1, happen in transaction 1, transaction 4, and 5. 3 transactions, item 1 repeated. So probability of having item I or support is 3 divided by 6. Item 2 repeated in all the transactions, so the probability is 6 divided by 6. Like support of 1 and 2, 1 and 2 repeated in 3 transactions, so their probability of their support is 3 divided by 6. So do you guys remember the probability rule, right? Okay. So item 2 and 3 happen in transaction 1, 2, 3, and 5. So 4 out of 6, and the support is 4 divided by 6. And you can calculate the support for 3 items together. So like 1 to 4. So which is like 3 divided by 6. Any questions so far? I think it should be straightforward. Oops. Then let's calculate the confidence of antecedent 1, consequent 2. Do you remember the formula of confidence? Let's go here. Confidence of B given A, or A antecedent of B, is the probability of the union divided by A, or antecedent. So the confidence is support, which is probability of union, divided by probability of antecedent. So here, antecedent is 1. What is probability of 1? In how many items 1 repeated? 3 divided by 6. So what is probability of their union? How many times 1 and 2 repeated together? So how many times 1 and 2 repeated? Okay, let me use my together the union. 3. Okay. So let me use my So
Hamid, I cannot hear you.
can you hear me? ولا Can you hear me now? Oh my god. What can I do? Can you hear me now?
Yes.
Can you hear me? No?
Yes.
Okay, that's great. So these are 6 transactions. We have transaction number here. And the items that are sold together. So confidence of 1 as an antecedent and 2 as a consequence is probability of 1 and 2 together, or the union divided by probability of 1. So how many times 1 and 2 repeated? In the first transaction here, in this transaction, in this transaction, and this transaction. So probability of 1 and 2 together is 3 divided by 6. What about probability of 1? It is written again, this item, this transaction, this transaction, this transaction. 3 out of 6 is equal 1. So we don't see any strong association relation. So you don't have to, if it's about a store, you don't have to put item 1 and 2 together, because the lift is not significantly large. It's not more than 1. What about 1 and 2 as an antecedent and 4 as a consequent? We should take care of probability of 1, 2, and 4. It happened this transaction, and this one. So 3 out of 6, and probability of 1 and 2 is 3 out of 6, because in 3 transactions, both of them happen together. So their association, their lift, the confidence is 1. Sorry, here we talk about confidence, not a lift. Any question? I think, okay, great. So, I think this example is much more straightforward. We want to calculate lift of A as an antecedent and 0 as a consequent. Again, these are ID numbers, so we're not sure what exactly they are. So anyway, we want to calculate the lift. Let's go, what was the lift formula? So probability of union divided by probability of A times probability of B. If I go here, so how many transactions we have? 1, 2, 3, 4, 5, 6, 7. What is probability of A and 0 together? How many transactions both of them happen together?
Zero, right?
1 and A and 0, yes. 3. So probability of their union is 3 out of 7. What is probability of A? It happened 4 transactions out of 7 transactions. So probability of A is 4 divided by 7. What about probability of, or instead of probability, can I say support? What is the probability or support of 0? It happened again in 4 out of 7 transactions. So based on the previous formula that we just talked about, that the lift is 1.31. So do you if these are 2 items of a grocery store, do you put them together or not?
Yes.
Why?
More than one.
Yes, the lift is more than one. So we would be more than happy to put them together. So as you see, these are just 4 items. So we had 2 antecedents of A and B and 2 consequences of 0 and 1. Even for this, it might take a couple of minutes, but usually in department stores or Amazon, they have 1 million items. So you cannot do it everything manually. So in such a cases, we should use software, and KNIME helps you to easily calculate that. So it calculates confidence, support, percentages, whatever. But for you, the most important thing is lift. So we want you, because you might need to redesign your website or your store. So you want to see, based on different consequences and antecedents, what would be the association rule to design your store, either online or a physical store. Any questions so far? So let me summarize the big picture. So basically, you have thousands of items either in your store, millions of, if your physical store, or millions of items in the online store. You can put them in random locations, but you want to have a wise decision. You are a business analyst or somebody with a business degree, you should come up with an objective way of putting them together. One way, doing a survey, and another one, just gradually improve the design of your store by looking at association rule. Another thing that you can keep in mind is, on top of selling more, is how comfortable is shopping your store. For example, if you go to a store that you need to walk more than 1 mile, it gets you super tired. So the customer would feel a lot more comfortable in their store. They can find whatever they want in super fast. So it may not be that much interesting if you go to for example, Walmart is the most general store, but let's say you go to Walmart and they put like vegetables next to the car tools that you need for fixing your car, and then maybe some crackers, then maybe some clothes. So if they just randomly put everything there, it would be a headache for you to go shopping there. So also you want to improve your customer experiences on top of selling more, which at the end probably you sell more if your customers are more comfortable. It helps your business. So at the end, maybe money counts. But anyway, you should have an objective way of designing them. For example, if you get hired by Walmart, you should have an objective measure to say why you think these items should go together. And the objective approach is rule, association rule, or market basket analysis. In the real cases, I mean, you cannot do everything manually. It takes forever also. So we need to use the software. Here we do KNIME. So is it one of the easiest algorithms that you can implement through KNIME. So you just need the input. You just need a cell splitter, because like here, all of the items are in the one cell. You just need to put them in this separate cells, or let KNIME knows that they are separated. So maybe KNIME separate them in the KNIME-friendly format that is not distinguished for you, but that is KNIME's know that within one cell, there is not just one item, there are several items. Like here, there's like 4 SKUs of 1, 2, 3, 4 here. So previous class, some of your friends bring a concern about learning KNIME, or maybe Tableau or other softwares that we do in this course. Basically, in this course, you learn how to communicate with the expert in certain areas. And also, you can do good experiences by yourself too. But, this course could be for detailed understanding. It needs to be taught. It needs to be taught at least 5 separate courses. So here we just summarize everything in one course for you to be able to communicate with the expert in the fields. For rule association rule, it's super easy for you. You see all the needed details here. But for example, in prescriptive part or predictive part, it's usually like 3 or 4 courses that we try to minimize everything in the 9 workflow, so you can learn how. For me, as long as the whole of the process is crystal clear for you, that would be really good. Also, so you might, because some of your friends were not in the discussion in the last class, so you want to do some good experiment for yourself, but we haven't had time to explain every module one by one. What can you do for even your final project or future? Use these workflows as a base and add something on top of that. You don't need to redesign everything from scratch. So for example, I use 5-fold calculation, you can put 10-fold. Maybe I use ROC. You can Google it what is the module for sensitivity or specificity. Or we haven't had any visualization here. Maybe you want to show a pie chart in 9, you can just Google how to show a pie chart in 9. So you can use these workflows as a base and just add more complex item on top of it. Or if you work with the analyst, probably they are very good at Python, you can give your workflow to them and just tell them, connect your Python to this 9 and give me the result. So anyway, so as I said, we didn't have we didn't have time to go to many details, and also even for your project or future, you can just whatever. Let's say you want to image processing, and we haven't had time to go over image processing. Just Google how to do image processing in 9, and probably you get a workflow from someone. You can add more details to that workflow to make it suitable for your needs. Like here, for today, I mean, this 3 module is enough. It could be a base that I can add something on top of that. So, any questions?
Just one question. The antecedent and consequent that we define that this is antecedent and that one is consequent. Is it based on which one we purchased first, or like the item went together in a market basket?
Actually, here, for example, you can consider any possible combination. For example, here we just look at one. Let's say one as A or antecedent to consequent. We didn't consider 3 antecedent for consequent, but it could be much more than that. So when you use software, consider any possible combinations. But manually here you just pick 5 just for visualization, just for learning how to do that. But for sure it's more than 5. So for today, these 3 is enough. Even if I give you assignment, you just read the file, split the cell, because in one cell it could be several items. We need 9 nodes that column contains several items. And then just let 9 find the association rule for us. if you get hired in a company that they need to redesign their store, you can just look at the outcome of this module, association rule learner, and look at the highest lift association, and anything more than one shows a good or a high association, the items that should go together. I assume based on the location, the items might be different. So for example, if there's there's some Walmart, smaller size Walmart, they call it local Walmarts or neighborhood Walmarts. So for example, if there's a small neighborhood Walmart inside the Boston, maybe there is a high association between, maybe there is not that much of association between gardening part or grocery part, but let's say there's a Walmart in the very suburban area. People probably prefer to have enough space for gardening. Maybe you can put those items more closer to each other. So based on each area, the association rule might be different. Or there is some Walmarts out of United States. So probably those locations based on certain local needs, the location of items might be different. Or maybe if there is not that much association between gardening items and other items in the downtown Boston, maybe they remove the gardening section there. If there is not that much of association or there is not that much of sale. Okay, please download the KNIME workflow from your Moodle and load it within your KNIME software. Here I provide an example of how you can build on top of the basic workflows that I give to you. Again, the reason we don't have that much of time to go through details, but for your project or later use, you can easily add further modules on the basic modules that you learn and just keep increasing it. And the good thing about KNIME is a free software, so probably is very easy for you to communicate with others because same as Python or R, there's a free software, so everybody may use it. So look at my PowerPoint. In my PowerPoint, I just said 3 is enough. One for reading, another one for splitting the cell, and the last one for calculating the association. Same here, they're enough. So in table reader, similar to previous one, I just identify a transaction table from 9. You can leave the remaining as default. So if you run it, let me reset, then execute. I have a row ID and so many items in each cell. These are the items that sort together, and look at all the transactions. Calculating lift, confidence, and support is a lot difficult here. So with case splitter, I'm just saying that if there's any tab or space, just split the cell for me. So as you see, there is a space within that cell. It means if between numbers there is a space, here, do you see there's a So if there is a space, just split the column 0 for me. Let's run it, execute. Is splitted, but it's like readable for KNIME. It's not a human-friendly format. It's just in the format that KNIMEs understand that the items are split. So here, if you look at the numbers, between them is a space, but you might insert a file that within numbers there is a comma. So if in that case, if you want to split here, oh no, here, instead of space, you put a comma. Means whenever you see a comma, split the item. But it's not the case here. As you see, between numbers there is a space. So I told KNIME, if you see a space, it means they are separate items. Again, they are separated, but in the KNIME format. So you remember we had the sentiment analysis. So everything was like in one column. So this is easier for KNIME to process. So there is no mathematics so far. We just import our data and convert it in the KNIME-friendly format. And the last part, we're just saying that all of the splitted items are in this column. And you can consider minimum size, minimum support. These are arbitrary. You can just change it later if you want. So I just said I want minimum support of 10, or I can put it 2. Doesn't matter. It's just a subjective matter. Minimum confidence to be 10. So again, these are arbitrary. You can leave it as default, or if you want to limit your support and confidence to certain numbers, you can just change these two. But here I'm just saying I want to see minimum support of 10 and minimum confidence of 10. Okay, right click and execute. So if I give you assignment, that's enough so far. But let's see what we can extra thing that we can do. Let's open the association rule learner. So as you see, we have first we have consequent, antecedent, could be more than one. Then item support, relative support. We haven't covered all of them, but there is, okay, this is rule. So if I sort them descending, the first one is the highest rule association between item 91 and 58. So if you want to redesign, you look at the store, if their distances are far from each other, or in your website, you can put it together, or in your website, whenever somebody buy 58, because it's antecedent, you can put an ad or link of 91 in the same page, so the person probably would buy it. It's more comfortable for them, and also makes more money for you. So any questions so far? I sorted the items, so probably, so if you want to sort based on, let's say, support, right click, sorry, click, not right click, just click, sort ascending, or again, I click descending. So some of them don't have antecedents. Because in some rows, we just consider them as a separate item. We want to see what's their own consequence if there is no antecedent. So any questions so far? As you see, this one is easy, but what can else we do? One of the, you can use it to find the items, but these are item IDs. So in consequent and antecedent, we just see IDs. We don't see actual name. I mean, probably if you work somewhere, you can easily just print this one and find it manually, but let's do it automatically. So on top of this basic name, I want to connect it to another table that has basically item names. So if you look at this table there, now I'm importing another table that shows me what does each number means. This is from NIME website too. Let me reset and rerun it. Execute. Then I right click and read table. So now we have item ID, price, and product name. Again, if you, let me show it here. Item and price, both of them are considered as a numerical value here. Do you see? If I go here, consequent is a string. Do you see? So let me show it again. So when I enter it, if I go to the column specification, the item is considered as a numerical value because it's happened automatically. Now I'm just guess the type of the column. We didn't do anything, just NIME guessed for us. If I go to the outcome of association rule learner, right click, then association table. If I go to second tab, so this is the first one, which all of the associations. The second one has the specification of column, and as you see, consequent here is a string. What I'm doing, I want to join these two tables based on the consequent ID and item ID. Because in one table, I have item ID and item names. In this one, we just have consequent, which is similar thing. I mean, it has different name, but basically in the consequent, you have item IDs too. So again, here we have item. Here, I have consequent ID. So, but in this one, they are considered as a string. When I import it, it's considered as a numerical value. I want to join these two tables together based on their similarity. So hopefully this time I can show it here. So okay. Association. Let me cheat. One minute. Let's say consequent ID of 0, 1. Then I have lift. I have support and other columns. Maybe one of them was antecedents. So anyway, also we have another table that has item ID, price, product name. Here, 0 was Swiss cheese. 1 was cherry coke. And others. I want to use this column and insert it here as another column. So product name. How? Because we have 2 columns that refer to the item IDs or consequent ID. I know consequent IDs are coming Okay, sorry guys, we had internet issue for a moment. So if you association rule is module doesn't work on your system, you need to install and like patch. So could you install it on your system? Do you have? Could you run association rule now? Okay, let me see. It's working now. Okay. Okay. So anyway, we need to just connect this to table. So with this module, I convert item to a string. Now we join them. So we're just saying that get consequent from the association rule table. Then it's equivalent to the item column. Then everything is just let the remaining as a default. Okay, then we execute. If I right click and look at it. Now we added a new column, product name. So now we know what those consequences means. For example, the highest lift, let me just find it, right click, descending. So the highest leaf is for watermelon, shrimps, lobster. apples. So, but as you see, you just see consequent ID. You don't see antecedent. We can add another joiner to see whatever are those antecedents. Because we know this product name was by joining two tables based on the consequent ID. And these are basically just consequent, but we want to see what are those antecedents. Like what are 115 and 231 or 12. So sometimes we have 3 antecedents. So basically joining table is now more challenging because for antecedent it's not just 1, sometimes you have 3, 4. So now if I want to do another join that is a little more complex, which I explained in the next one. The idea is I ungroup based on antecedent. Let me just show it here. So okay, so now it's much more harder to join based on these 2 columns. We want to see what are those antecedents. One approach is ungrouping based on antecedent column, then joining them. So let me just explain what I mean. For example, if I ungroup based on this, I make it 3 rows of 0, 1, 2. This one would be 5. And this one would be 3, 1, 7. So, and we have other observations too. So basically we copied each row based on how many antecedents they have. If they have 4 antecedents, when we ungroup based on antecedent, it should make 4 rows. Now, let's call it ungrouped antecedent. We can merge based on their IDs now. You can easily join them because now each row has it has a separate ID. So for easier understanding, let me add another column here. So let's say here we have row ID. This ID would be 1, 2, 3. This one would be 1, 1, 1, 2, 3, 3, 3. Because I repeat the row 1 3 times. It had 3 antecedents, so it's repeated 3 times. So all other columns are same except for antecedent column. Now, after I join it, for example, if let's say this one is Swiss cheese, this one is cherry Coke, this one, let's say watermelon, or just water, this one Coke. In the next step, now I don't want to have multiple rows. I want to have all of them in one row. Again, I group them. We can easily group based on row IDs because it's a unique identifier. So if I group based on the same row, here instead of 0, I put Swiss cheese, cherry Coke, and what was 2? Water. And same for other. So I ungroup, join, then regroup. Again, as I said, you don't have to do that. So this is just an example of how we can add on top of a basic workflow. So for example, if you understand this, if you have previous knowledge of SQL, you know how to merge, how to join, those kind of things. So you can kind of use that, implement that knowledge here, but it's not what I'm expecting from you. So having said that, again, this 3 was enough. Here I add another branch for how to find consequence. Now here in this method node, I teach you how to, in these 2 method nodes, I teach you how to merge these 2. So the first one, I imported, first I imported transaction data. In the lower branch, I import the item data. So if you run it, this one is the previous one. I just convert then a split with a 9 friendly format. In the second one, I convert the item ID or item column to the string. Then I did rule association, similar to previous one. And I can find which one has the highest lift. Then the last method node, I ungroup, regroup to just put the names. So for example, here, I just define another column of row ID. Basically, I want to make a unique identifier. So later when I ungroup and regroup, I do based on I know how to regroup them. So in row ID, I'm just saying that make a new column, and the column is equal to my row ID, and the name is rule ID. So if you run it, as you see now, I have a rule ID column is exactly equal to my row IDs. Again, since later I want to regroup regroup them, it should be regrouped based on a unique ID. You don't want to just randomly regroup them. The identifier is just row IDs. So anyway, now is the challenging part. So we ungroup them. If you look at the configuration, I'm just saying based on antecedent column, ungroup my transactions. So if in one row of antecedent, I have 3 transactions, now you should see 3 rows. Let's run it and see. Let's see, ungroup. Let's execute. Hopefully I can find a good observation to show you. Okay, look at this tree. All of them has row ID of 1929. Look at all of them has antecedents, similar antecedent. So everything is same exact new column. So I just separate them based on based on unique antecedent items. You see? So 117, this row. 231 is the middle, this row. 12 is this row. So everything else is same. I just repeated based on how many antecedents they have. Any questions so far? Again, this is something extra material. You don't have to do that in your assignment or project, but if still you have questions, just let me know. I don't expect you to be very good at SQL at this point, so no worries if it's not too clear for you. This is just an example of how you can use, if you're very good in SQL, you can use that knowledge embed in 9. You can Google it how to do such a transactions and use it here. But I don't expect to be very clear for everyone. But if you have any questions, just let me know. Let's see what happens if we do a joiner. So we join the items that we have. If I open it, the item based on the new antecedent column that I created. Then I right-click, execute. Let's open it. Let me just sort. Okay, look at here. So row ID of 98. So the consequent, let me just expand it. All of them have consequent of 48. They have 3 antecedent of 117, 235, and 12. 117 is tuna, 235 is lobster, and 12 is shrimps. So now you can understand why I created multiple rows, because later I want to join them based on item names. Again, no worries, it's kind of fuzzy for you, but this is some, again, it's an example of extra thing that you can do. Now, I group them again based on row ID. Instead of having multiple rows, I want, if I already created 3 different rows, I want to merge them in one row. Because everything is, all the information is same. I just had an extra column of item names. So here, can anyone say why I use row ID to group them together? Let me close the window. So this one is what I'm not sure. Maybe I'm not enough. So, okay, why we use rule ID to merge the rows?
I think because in rule ID column we have the common row numbers.
Yes.
Repeated numbers. So it's easy to group.
Yeah, your first answer is very right. When you want to group them together, you should group based on common item. So here, the common identifier is role ID. So for example, this one,
I cannot hear you.
can you hear me now?
Oh, yes.
So there's so many technical issues today. So anyway, I just said when I wanted to group them together, I did some extra calculation. For example, finding the summation, the first item when you group. So because there are 3 rows, if all of them are same, you can just pick the first one because it doesn't matter. They have same thing. Or you can find the mean. These are something extra. It's out of content for now. But the only important thing for us here, when we group them together, all of the antecedents merged into one column. So we merge antecedent. What about consequence? We already did consequence. We need to do another joiner. So this time we have one consequent ID. We have item ID. We merge them together or join them together. So here I have an extra column for renaming. Some of the names doesn't look good, so I just rename them. This is something extra. You don't have to do that. But the last one. So this time I want to find a consequent ID. Okay, right click, execute. Now if I open it, you can see, you can rename the columns again, but you can see, for example, yogurt has two antecedents of tuna and shrimp. What is the lift? Let me find the lift. Let's sort based on lift. So I'm probably two different watermelons anyway. But for example, the next one is shrimp. Okay, so again, in this class, instead of just teaching you first three, which is like importing the data and finding association rule, as you see, if you do just first three modules, you can find the highest association, but you don't have antecedent ID and consequent ID. So we did some extra thing to find what are my antecedent, what those antecedent IDs means, and what those consequent IDs means. What can you do? You can export this table and do what I said exactly in SQL. So you don't have to do everything here. But as you see, we can use extra module to find antecedent ID and consequent IDs. Again, just let me summarize what I said. So it might be ambiguous for you to do from scratch. So you can use these modules as your base workflow and just search what you need and add on top of these modules. So you don't need to make everything from scratch. Even your friends who did antics programming with me, they didn't do everything from scratch. They just Google some Python codes, use it in their programming project, and just they add on top of those codes. So whenever if you do it several 1,000 times, you can even do from scratch. But if it's your first time, it's better to use other workflows as a base and just add some modules on top of that. So for your assignment, use any of those workflows that I put there. It's fine. You can even just use the first 3. So just do 3 visualizations. Try to make 3 figures, anything. It could be histogram, it could be pie chart, it could be like bar chart, whatever table, or a simple regression. So just Google and show me 3 visualizations within 9. That would be more than enough. So you can use any of, so you can see how to use those workflow as a base, add something on top of that. One pie chart, let's see. Or maybe you can report histogram of rule IDs or histogram of I think this one might be easier. This one. This one has more numerical values. Yeah, I think 2 is enough. Just make 2 visualization from these 2 tables. The point is not have, if you have a good visualization, is informative, is more than enough. But I just want you guys to see that you can just Google based on your need, add something on top of this workflow. Any questions? Again, you can export it to the Tableau and do it in Tableau too. That's fine. But for today, I mean, probably if you export your association rule into Tableau, you can make a much more fancier visualization, because Tableau is much better software for visualization. But it's just a practice how to expand the workflows to do extra things. That's it. Any questions? Any question from people over Zoom? Again, sorry, today we have some technical issues. We disconnected several times, and it made such like I think 2 or 3 videos. So I should merge them together for the people who are taking as asynchronous. Hopefully it works. Okay, so if there's no question, that's for today, and thank you very much.